Hello, today we are doing the second part of 7.4, parallel lines and proportional parts. So yesterday we discussed the triangle proportionality theorem. So we saw that triangles contain a line that is parallel to one of its sides. The two triangles formed can be proved similar using the angle-angle similarity postulate. Since the triangles are similar, their sides are proportional. So we were able to, instead of looking at just the smaller triangle and the bigger triangle, while that's still totally fine, we could actually break it down and look at the smaller pieces, or not even the whole sides at all. So we did some cross multiplying to solve there. Then we looked at the converse of this. We checked to see if these sides were proportional, and then we saw that these sides are parallel, the two specific ones that might be parallel. And then we saw the midsegment of a triangle theorem, or triangle midsegment theorem, and we learned that the midsegment is half the length of the side, okay? It's parallel side specifically. Now, it does have to be parallel for this to work. So we did some simple multiplying and dividing by 2, and we found some angles with some of our older theorems, specifically alternate interior angles theorem. And this brings us to where we are starting today. Okay, so we have proportional parts with parallel lines. Another special case of the triangle proportionality theorem involves 3 or more parallel lines cut by 2 transversals. So you have your parallel lines here, 1, 2, 3, and there are 2 transversals. If you notice these transversals get extended, they will form a triangle. So that's what it says here. Notice that if transversals A and B are extended, they form triangles with the parallel lines. So there's actually multiple triangles. You have one big one, and then you have a bunch of little ones. So we have a corollary, proportional parts of parallel lines. If 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. Okay, so if AE, this guy, is parallel to BF, is parallel to CG, then you know that AB over BC is equal to EF over FG. So we can set up a problem here. It's really similar to what we saw above. So we're going to use proportional segments of transversals. In the figure, we have Larch, Maple, and Nuthatch streets. They are all parallel. So it's probably a good idea to go ahead and mark these as parallel. So we have parallel, and we have parallel. The figure shows the distance in between city blocks. So you have, I don't know what units, 26 yards, 13 yards, doesn't really matter. We have 16 and we have X. We want to figure out the distance between Larch and Maple streets on this other road. So what we can do based on our corollary here is we can take 13 over 26. You can just take the pairs here, and we equal that to 16 over X. Because I put 13 on top, 16 has to go on top on this other side. Okay? Cross multiply to solve, have a calculator available. You get 13x equals 416. Divide by 13, x equals 32. Okay? We knew it had to be bigger because 16 is bigger than 13, so it has to be bigger than 26. And we got 32. All right, pause the video. You guys try this, you try. All right, hopefully it was paused for long enough. Let's take a look at it. In the figure, Davis, Broad, and Main Streets are all parallel. Mark it. Davis, Broad, Main Streets. The figure shows the distances in between city blocks. Find X. So, same idea. We don't have to look at like a whole triangle or anything. This is really just parts of triangles. We can just match things up. So I'm going to take 15 over x, write that out. This will match up to 24 over 8. Now this should be smaller than 8 because 24 is bigger than 15. We'll just see. We can think through it later. So we have 24x equals 120 because 15 times 8 is 120. We divide by 24. This gives us that x is equal to 5. And 5 is smaller than 8, which we already knew needed to be the case. All right, flip paper. We have another corollary, congruent parts of parallel lines. This mixes things up, guys. For most of these problems this chapter, we are setting up proportions to solve. This is not the case for these problems. If 3 or more parallel lines cut off congruent segments on one transversal, notice how these are marked congruent, then they cut off congruent segments on every transversal. So if AB and BC are congruent as they are marked here, that means EF and FG must also be congruent no matter where that line lies. So for this problem, we are back to solving with congruents, equaling them. Do not set up a proportion, okay? So you're going to have to know when you can do what. Basically, if there are congruences marked, equal them. If they're not marked, think about your other theorems. Probably set up a proportion in most cases this chapter. So I'm going to equal them to solve because they are marked congruent up here. 3x minus 7 equals x plus 5. I have 2x equals 12. So x equals 6. Easy enough. If it asked us to plug it back in and find the actual segment lengths, we could, but it didn't. It asked for x and y. So now I'm going to transition and I am going to solve for y based on my corollary above. Since these two are congruent, that means that these two also must be congruent. Don't overthink it too much. So we have 9y minus 2 equals 6y plus 4. My bad. So I go ahead and solve. Simple as that. Hopefully, after all this proportion stuff, we go back to doing this normal solving and you're like, wow, that's easy. You should end up with y equal to 2. Once again, we don't have to plug it back in. We're not guaranteed that they are all congruent. We're only guaranteed that the pairs that are marked are congruent. Probably thought I should make that distinction. So these two are the same, and the two circled in red are the same. All right, pause the video, try the last one. Let's get started here. So we are guaranteed that these two are the same. We have 4a minus 5 equals 3a plus 6. They're marked congruent. Easy peasy. I do my solving. I like to do it all in one step, guys. Just like so. This gives me 1a equals 11, which basically means that a equals 11. The second one is a tad bit trickier. Once again, because those two were marked congruent, these two also have to be congruent. The only reason this other one is trickier is because there is a fraction. Don't freak out about it. We'll go through it with the fraction. Anytime there is a denominator of a 3, I would not suggest switching that to a decimal because you'd have a repeating decimal and then you'd have to deal with that and you would end up with rounding error and it's not super fun. So we have to get all of our b terms together, which means we need to subtract this fraction right away. Here's the deal. 3b and 5 over 3b don't have the same common denominator. So I need to figure out how to get 3 to have a denominator of 3. So I'm just going to multiply by 3. Top and bottom, this will not change it. 9 over the 3 is the same as just 3, because 9 divided by 3 is 3. This means up here I was subtracting 5 over 3. So this gives me 4 over 3. Okay, so 3 minus 5 over 3 is 4 over 3. If you weren't sure on that, that's fine. The fraction does make it a tad bit trickier, and it is 4 over 3b. Now this still equals 2 on the other side. The 2 just comes down. From here, you can't divide a fraction. You have to multiply by the flip. Or I like to say can't divide a fraction. We have to multiply by the reciprocal. That is how I learned it. So now that I have that, I can actually finish solving. Maybe. Okay, let's just move this whole thing then. So to solve, I can either do two things. I can reduce the 2 and the 4 right away, or I can just multiply straight across from now because these guys have canceled out. I'm really close to having b by itself. I can do 6 over 4. They're both even. They need to be reduced to 3 over 2. Or I could have reduced earlier. Either way, we would get the same answer. 3 over 2 is b. If you did decimal stuff, you should end up with 1.5, although you would have had to have kept all of your decimals so you didn't get rounding error. So go back through. If you got rounding error, write it out as a fraction. I know fractions can be kind of intimidating, but they actually keep your answers in a better form than decimals in most cases. All right, if you have extra time after this video, I would like you to finish the delta, the 7374 delta. That's due on Tuesday for full credit. I'll just get your scores next week, Monday or Tuesday. If you were already done with that, flip your paper over, work on the little worksheet, go through these problems. I promise, even though I don't take them for a grade, they can be super helpful to make sure you really truly understand, okay? So use your time wisely. You can move around if you want to, but don't be a distraction to others. Have a great day.